password I can't tell you. Function or the lower sublayer of the media control implementations. For remarkable, you do have PCF has not been properly implemented in today's 802.11 product. It's usually the DCF that's widely used, and mostly because of the fact that it allows for contentions. It's designed as a contention algorithm. Okay, so one of those things that you have to keep note of, which is quite efficient for addressing a lot of traffic issues, as I was saying, within wireless cellular networks. Okay, so these are two sublayer solutions that are implemented, but today the most widely used are the lower sublayers, which is the contention algorithms, because the fact that we understood that there are a lot of contention within most cellular network implementations. Okay, but in a Wi-Fi environment, in the early days, this was much more ideal because there wasn't a lot of wireless devices or wireless implementation. But today, Wi-Fi has evolved and outgrown its name. Now we have Wi-Fi 5 and 6, and they keep going on and on and on. And they have an A and X versions of it. So they are addressing a number of interference issues that relates collisions. And so with some of these things, you have to go with the ones that use the contention algorithms to provide access to all the various traffics that counts with either the A, B, G, N, A, or X, or C versions of, and as well as the Wi-Fi 6, 7, and what have you that are coming up these days. Okay, so it's just a way of mitigating challenges with the wireless LANs in current days. Okay, and you see there the architecture protocol setups, a number of layouts for the 2.4 gigahertz, the MAC aspect of it, and then the logic unit, which is the data link layer aspect of it, how it's been controlled, and inter-collisions are avoided using the interference space. I think some APs also have this implementation on their OS to manage collisions as well. So in this case, you have carrier sense multiple access with collision avoidance as a way to mitigate against a collision within wireless environments. And here I do have a general DCF, which is your distribution, the one with the contention algorithm, being deployed, or in terms of its pseudo implementation, I have what's the name of this again? Diagram I call it. Sure, I forgot the name again. The name of this is the process. There's a technical word for this design layout. Anyone knows? I've forgotten the name. It's the diagram flow. There you go. The design diagram flow of how the DCF works. So this is the flow diagram. The flow diagram of how the DCF works. So it goes from waiting for frames to be transmitted. Media is either idle. There's a no transmission coming through when it's not idle, or when it's actually not idle. Then you go for a wait for the interframe space. And once it's accomplished, then you have a bit of a waiting time to make sure that there's no transmission coming through. And once there's no transmission, then you can actually forward a frame back and forth. But on the other hand, if the medium is actually idle, then you go to a wait until current transmission ends before you actually forward any information that comes through. So it's a way of mitigating against the request to send and then collect to send information. basically, this is the algorithm or the flow diagram that manages how the distributed coordination function actually works within the carrier sense multiple access for collision avoidance to take effect. So at least users conform to these rules over here. Where are the rules over here? I'm trying to look for the rules of, there we go, these are the rules. So usually when the station with a frame to transmit sends the medium, if the medium is idle, it waits to see if the medium remains idle for a given time, for an equal time, which is called the interframe space, or it's called the delay time, just to basically make sure that it's like crossing a road. When you're going to cross a road, a zebra crossing, you look left and right, and they say look left again, right? The whole essence to make sure that you have that assurance that there are no car coming before you cross. So that's the whole essence of this part of the DCF implementation or algorithm to make sure there is no transmission in place. Then once there's no transmission going on, then the medium can actually decide to get a clear to send acknowledgement and then be able to forward information across. But on the other hand, if the medium is busy, the station will defer transmission and continues to monitor the medium until the current transmission is over. Okay, so when you're going to cross, you look left and right, and the car's coming, you wait. Okay, now once the transmission is over, the station delays another interface frame just to make sure, once again. So there is that thorough checking to make sure the medium is ideal before you actually send an information across. Basically, trying to avoid collision. Okay, so the DCF is helping us using the carrier sense multiple access with collision avoidance to basically make sure we can address collision within collision challenges within a wireless implementation. Now, if the medium remains idle for a period, then the station will back off a random amount of time and then again senses the medium. If the medium is still busy, there's still another transmission going place, then it would have to still keep backing off. Now, once the medium is completely less busy, then there is what? The transmission aspect of it that has to take effect. So if the transmission is unsuccessful, which means the transmission went through without getting a clear to send, and there's a collision, it has to basically wait for an acknowledgement to take place. So generally you have to wait for an acknowledgement to take effect before you know for a fact that a given message that was transmitted went through or not. It's kind of like this device here, send information to this guy. It was a clear to go, clear to send. But I realized that it's not getting acknowledgement from A that it has received the information that was sent. And it will basically say, okay, what's going on? Is there a collision along the line? Now, for a given period of time, if a time allocation is given for a transmission to be acknowledged, if that acknowledgement message doesn't come through, C is going to assume that A didn't get the message. So it has to basically re-forward information again, retransmit the information all over again. That's what is captured over here. So if the transmission is not successful, which is determined by the absence of an acknowledgement, then it assumes that collision has occurred. Now, to ensure that the backup remains stability, binary exponential backups are used. Why are we using that? Well, generally to avoid collision, right? So why not collision detection? Well, collision detection has got a way of practically acknowledging that the wireless network has got challenges. So in other terms, when you want to dynamically address some of this collision, you create dynamic ranges for wireless signals within a larger range. So at least when you're transmitting a station from another given device, if the devices or that station device is not able to distinguish incoming signals or in that sense has got noise, then it will acknowledge that there's an effect or there's a bit of a challenge with the transmission in terms of collision. So you have to basically find a different approach to address the collision avoidance within the carrier sense multiple access. And hence the reason why we prefer to go with the binary exponential backup, where we go through a number of exponential, we go through this whole scenario with probabilities and incorporate into it. What we say, what are the probabilities of this particular device, of maybe device C transmitting to A without a clear to send. We're basically using some algorithms to handle probabilities. And then once we calculate all those probabilities and we identify that, okay, we've covered all the probability, all the chances that A will transmit or C will transmit without a carrier sense, without a clear to send information, then we can go ahead and deploy or transmit our message so that we don't have any collisions within the transmissions. Okay, so that's where the binary potential exponential comes into place, where we use probabilities over here. So potential just means that exponential means we're just using our probabilities to address collision avoidance within a given wireless LAN implementation. So I went through the what you call the flow diagram with y'all, and coming to the security aspect of it, quite a number of issues, quite a number of key things that needs to be looked at: authentication, de-authentication, privacy, and what have you. For privacy, you can use encrypted standard for security. And the most widely used these days are the Wi-Fi protection access, which you can find over here. If I were to change this to, so call me with a password that I don't want you to know. If I were to basically make this an access point, and I need to change it, apply, and then LAN. I want to make it a router. So I get in a router base and then change it. Simple. Okay, I've been logged out of the system because of the bridge mode. So I need to basically see if I can reach it again. So ping 192.168.1.20. Okay, it's responding. Just got to reload it. Okay, so it's up now. So we have wireless as what? Access point, network, and then router. I'm not disabling any of the networks. And I'm going to bridge the, if you have an ISP or your main network, the internet's coming in, you configure it over here. Okay, either using a DHCP static or point-to-point over point-to-point power Ethernet protocols. Those are all part of the network protocols implementation that the ISPs provide for your connectivities to their network. We got all those over here. Now, if I'm able to do this, I should be able to, let me save it. I should be able to look at the encryption mode for the wireless settings. So you guys can see the WPAs. It's reloading again. Let me see if now it's not stable yet. timed out. Okay, so I've been timed out because when I switch it to a router base, the IP address is no more .1. It's actually .1. So if I were to do .1, I should get connectivity. Now it goes through. If I were to do that, I have two .1s on the network, so it might not go through, which sucks because the two .1s are going to create interference on my network. But let's see if it goes through. Because I have TP-Link on .1 and then I have Ubiquiti on .1. So I'm going to have a bit of a conflict. Yes, I can see the conflict going on. And that also means that I have to indicate the, yes, the TP-Link comes up. TP-Link is up over here, letting me know that I'm conflict. So there's a conflict over here. I'm using two IP addresses on the same network. So to resolve that issue, we're going to go back into the AP and then I'm going to manually reset it. So let's switch back to the, let me switch back to the display over here. So, so I'm going to reset this because now I have a conflict. This one has got a .1 and then my main network from my network router has .1. So that had two conflicting IPs on the same device. So that will give me an issue. So to reset it, I need to, you can use this pin over here. You can use any pin. This is a small pin over here. And then you go into the reset button right over there. That reset button. And we're going to push. You're going to push. There's a knob over there. We push hard on it for about 5 seconds. And then we'll do the reset for you. So I'm going to show you the reset. The reset shows that this device will blink to. All the signal lights will show up, letting you know that it's been reset. So keep an eye on that while I do the reset. Okay, pay attention, watch carefully. 1 second. Okay, watch. It will go red very soon. You see that? It's going red. You see the red signal? See the red? Yeah, it's red. It's gone now. It's reset now. It has been reset. So now if I go back to the command prompt, let me see. Yeah, it's almost fully reset. So let's go back to the 20 minus T and see if it goes through. So it's still resetting. Eventually, when it starts and it's fully reset, I should be able to say I'm going through now. It's going through now. You see, it's going through. So it means we can access the device again now. So if I were to go back to the .20, I should be able to get back into the firmware is loading. Okay, here we go. Okay, so it's in reset. So now I have to all over again. ENT, UBNT. Pick a country. Always pick US, or you can pick Ghana, but I prefer to pick US. Agree to the terms and condition, and then log in. Then I'm back into the system now. Okay. So what I wanted to show you guys was the WPA's security. Okay, here we go. So these are WPA's for this is our enterprise grade. These are for basic grades, which allows you to use a keyword. So your pass key for your, so we can say it's my name or something I don't want to show you. Yeah, I'm going to use my name over here as the SSID, the wireless IP address, password. So once that is set, then when somebody wants to connect to this device, they would have to use this passphrase or pass key after they connect to the SSID, UBNT. And once that happens, then they can be able to connect to the network and be able to have network services. So anyway, the WPA is what I was trying to showcase to you guys, the WPA. This is the wired equivalent privacy, which is not used these days. People are using this because it's much more protected or much more secure. So from a security point of view, this is the most effective privacy security standard to use or encryption standard to use for most of your wireless connectivity. We get so that in a way, in a sense, it's what wireless networks implementation is really all about. You can do a number of setups with it. The newer ones that are coming up these days, they address a number of things, a number of transmission needs. Like for instance, the TP-Link that I got are much more robust and very advanced. They address very, very advanced needs. So let's see. So on my network, and I don't want to show you guys now because otherwise you're going to see my login details. You guys are smart, so you might figure out what my login details are and then compromise my entire network. So I'm not going to show you that. But like I said, there are different, the new advanced version they have these days, they do a lot more fancy stuff. They're all designed to basically address wireless LAN needs. Okay. So anyways, that's give you more or less an overview of what wireless LAN is all about and how they're used to address a number of specific wireless demands or wireless implementation or deployment needs within a given environment. Okay, I'm going to pause over here for some questions. If you guys have any questions, you can talk, you can say it, or you can ask questions or what have you. So I'm going to allow you guys to unmute your mics and then if possible, ask questions. Okay, guys, you can unmute your mics now and ask questions if you want to get some clarification on some of these things. You guys can unmute your mics. I think I allow participants to unmute their mics. Yes. So anybody got a question? Yes or no? Any questions from you guys? I've gone through a number of stuff, you know, how to set up a basic wireless AP, some of the technical terms that you saw in the slides that are actually represented within the wireless AP devices that propagates the wireless LAN frequencies. I'm pretty sure you have some, you know, big contributions, comments that you want to put across. Unless you're just watching and me talking as usual. Any questions? Anything? Nothing? Okay. So if you guys don't have anything to say, you're just gonna stare. Then I'm gonna call it a day. Okay. Did I hear somebody say something?
Okay, sir.
And don't okay. This is what you guys do. It's annoying. Okay, so that's all. Didn't you have any like questions to ask? There was a whole lot of stuff that was going on over here. I showcased a number of stuff. You telling me you don't have an opinion? Oh, somebody says, sir, your video is on your this video here it's not uploaded on the course page, but I upload it because I'm recording it so I can upload it for you guys. Okay. But there are other videos that relates to the termination aspect of it, other designs, implementation or test modules that I've set up around it. But this one for the wireless LAN, I don't think I have the video, but I deleted it. So I'm going to use this to alter it. Okay. Okay, so Alex, sorry, Felix, you said your network was acting out. That's fine. I'll save it and upload it to the YouTube channel for you guys to have access to it. Anybody else got anything? Anything? Nothing? Okay. So I'm going to start the recording and then we'll call it a day, guys.